Okay, for this one, we're looking at patterns and nonlinear functions. So, looking at the quick vocabulary, this one is would be a linear function. This one obviously would not be a linear function, so that's considered a nonlinear function. This one would be considered a linear function, and this one would be considered a nonlinear function. All right, so pizza. Who doesn't like pizza? The area in square inches of a pizza is a function of the radius r in inches. The cost C in dollars of the sauce for pizza is a function of the weight in ounces of sauce used. Graph these functions shown by the tables below. Is each a function linear or nonlinear? So for this, it says the radius and the area, and then this one's the sauce cost, which is the weight and the cost of sauce. So if we look at this one, we go ahead and plot this. This is 2 and 12.5. So 2 and 12.5, it's like right here. And then the next one would be at 4 and 50.27. So 4 and 50.27. Oh, okay, so if I wanted to graph this first one, I believe it is 2 and 12.57. So I'm going to go 2 and 12.57. That looks about right there. And then the next point is 4 and 50.7. And then the next one would be 6 and 113.12. So 6 and 113.12. And then 8 and 201. 10 and 314. So I can see here that this definitely is not going to be a linear. It looks more like wavy. So that would be a non-linear function. If you look at the next one, sauce versus or sauce cost, so weight versus sauce. So on this one, you have 2 and 80 cents. So we're probably like right here, and then 4 and $1.60. So 4 and $1.60. 6 and 240. Looks something about like that. And then you say 8 and 320. And it looks about like that. And 10 and $4. So 10 and $4 looks about like that. If you look at this, I would say, yeah, that's probably pretty good. Pretty much a line. Looks pretty linear to me. So for sure, that one is a linear function. So for the got it, it says the table shows the fraction a of the original area of a piece of paper that remains after the paper has been cut in half n times. Graph the function represented by the table. Is it linear or nonlinear? So just do the same thing. Just go ahead and make yourself an x and a y axis. Plot it and see if it looks like a linear. If it doesn't walk like a duck and it doesn't quack like a duck, then it's not a duck. So make it like just if it looks linear, say it's linear. All right, let's do another example. The table shows the total number of blocks in each figure below as a function of the number of blocks on one edge. What is a pattern you can use to complete the table? Represent the relationship using words, an equation, and a graph. So this goes back to like stuff from before. Now, if you look at this, number of blocks on edge X. So there's one block, total number of blocks Y, one block, so it's 1, 1. This one we use 2 blocks on an edge. How many blocks do we use? We used 1, 2, 3, 4, 5, 6, 7, and the one behind it, 8. So 2, 8. For 3, we did, here's 3 this way and there's 3 that way, and then it looks like there's 27. So would you see some sort of pattern that we can do here? 1, 1, 2, 8, 3, 27. So if we have 4, how many total blocks will we need to make that figure? Now this takes a little bit of pizzazz. If you look at this a little bit more and you say, okay, well, how does the 2 become the 8? How does the 3 become the 27? Well, this is a 2 by 2 by 2. That is, it's 2 length, 2 wide, and 2 high. This is 3 long, 3 wide, and 3 high. So this would be 4. The next one would be 4 times 4 times 4. Or what we could say, what's 4 to the third power? Well, I believe that is 64, right? So this would be 4 comma 64. And then 5 times 5 times 5, or 125. So then this would be a 5 comma 125. So 5 comma 125. Now you can try to do it to make it like a pattern. How is this 2 becoming an 8? How is that 3 becoming a 27? We said it was 3 times 3 times 3, or 4 times 4 times 4, or 5 times 5 times 5. Or we could say y is equal to x taken to the third power, or y equals x cubed. And in there, just by saying that, you can say it in words. The words would say the total number of blocks y is the cube of the number of blocks on an edge. Now, what would this look like if we were to graph it? Now, if we were to graph it, if we go to 1, 1, we go 1, 1, it's probably like right about here. And then the next one was 3, 9, so we're probably like right there. Actually, you're up a little bit. And then 4, what was 4? Oh, I'm sorry. Goof that up a little bit. It is 2 and then 8. It is 2 and then 8. Let me rewind that a little bit. So that's 1, 1, 2, 8, 3, 27, 4 and 64, 5 and 125. And you can see that it's just taking that curve. That would be a cubic non-linear function is what we call it. It's a non-linear function. Now for the got it, you're going to do the same thing. You're just going to see if the table, see if you can see some sort of branch, how many branches it is. See the relationship. See if you can come up with it. All right. So go ahead and do that one. Let's do one more. The ordered pairs 1, 2, 2, 4, 3, 8, 4, 16, and 5, 32 represent a function. What is the rule that represents this function? So if I were to do this, if I were to put this in a table of values, because sometimes when you put it in a table of values, it's easier to see. So if I went ahead and put this in a table of values, and I just said, okay, I'm going to go ahead and make this 1, 2, and then that's 2, 4, and then that's 3, 8, and then there's 4, 16, and then there's 5 and 32. I'm going to look at that and I'm going to say, okay, well, y is equal to. Now, what is y equal to? What's happening constantly? Let's see, you got 1 going to 2, and a 2 going to a 4, and a 3 going to an 8, and a 4 going to 16, and a 5 going to a 32. How is that working? 1 going to a 2, 2 going to a 4, 3 going to an 8, 4 going to a 16, and a 5, 32. They're all related somehow. Let's see. I don't know. They're all even. I don't know. Let's see. 2 to the first power is 2. 2 to the second power is 4. 2 cubed is 8. 2 to the fourth. There you go. You got it. Y equals 2 to the power of x. That's a kind of tricky one, but it does happen. I mean, it's not always sunshine, rainbows, and linear functions. Usually you have to do some thinking and have some more challenging nonlinear functions. Okay, so what you need to do is you need to do the got it, and you need to make sure you do the lesson check and do you understand in your guide notes, and I will probably be collecting those tomorrow in class. All right, I'll see you tomorrow, and may the force be with you.